Welcome to Climate Honesty, where we simplify complex topics to help you be better informed on energy and climate. I've been in the energy field almost 4 decades in varying capacities in oil and gas, in pollution control, in rocket engines, and solar technology. Join me as we take an honest look at solar technology. Solar energy is often touted as the ultimate in clean energy. We have an unlimited supply from the sun. We can convert sunlight directly into electricity, and there appears to be no emissions. As with everything, solar comes with a cost, both financially and environmentally. It takes a lot of energy to make a solar cell. And this is where we're lacking a little bit of honesty in the environmental impact of solar technology. In this video, I'm going to show you how solar cells are made, but also how they're evaluated from a life cycle analysis standpoint. In order to make a photovoltaic cell, or a solar cell as we'll call it here, we have to mine quartz from the earth. So there's mining involved. We then have to ship it to wherever we're going to process it. And our processing starts out with what's called an electric arc furnace or a carbon arc furnace. And what this is it's kind of like a giant welder. We basically add a bunch of electricity and create an arc, and this melts the quartz rock at about over 2,000 degrees Fahrenheit. And what we get out of that is carbon monoxide gas and silicon. Now, we also have to add coal or coke in order for the process to work. What comes out of the electric arc furnace is a metallurgical grade silicon, and we have to process that further in order to make an electronic grade silicon. There are several different ways to further process the silicon. They all require some form of heat, and then I typically contact it with a gas or something else, and I pull the impurities out of it, and I end up with a very acidic condensate afterwards. Now, I've worked in plants where we had to use double wall piping, because what was inside was so acidic and so toxic that if it leaked out, bad things would happen. In order to make electronics grade silicon, it takes mining and all the associated fossil fuels required for that. It takes a large amount of electricity, which is why many of the plants are located close to hydroelectric power, and it produces acid and carbon monoxide. Once we have electronics grade silicon, we create what's called a boule, which is essentially a cylinder, and we cut that cylinder into very thin wafers, about 1/2 millimeter thick, and that's what becomes a solar cell. We then combine those solar cells together to make a solar panel. The panel is made by wiring these solar cells together, attaching it to a mylar or a glass backing, and then putting it in an aluminum frame. And that's what you see when you see a solar panel. In order to do an honest evaluation of solar cell manufacturing, we need to look at everything it takes to make a solar panel. That includes the manufacturing of the glass, the aluminum, the copper wire, any special coatings required, and any waste products that come out of any of those processes. I went through all the details of showing what it takes to make a solar cell to show you how energy intensive a solar cell is. It takes a lot of energy to make a solar cell that produces electricity. In order to compare solar to other forms of electricity generation, we need to do something called a life cycle analysis. Over the past 30 years, hundreds of life cycle analyses have been performed on solar energy. The National Renewable Energy Laboratory has gone through and normalized some of these analyses so that we're comparing apples to apples, such as how much sun is arriving at the solar cell, how long the solar cell lasts, etc. What we get out of a life cycle analysis is the amount of greenhouse gases, or grams of CO2, per unit of energy. So many grams of CO2 per kilowatt hour. We use this to compare different types of technology. One of the things that is not normalized in these life cycle analysis is where that electricity comes from. This is a very important point because it makes a huge difference on the amount of greenhouse gases created per kilowatt hour. We need to look at where our electricity comes from in order to do a true assessment of solar technology. Now, most solar cells are actually manufactured in China right now, and that electricity used to make those solar cells is primarily made from coal. It's also true that most of the electricity generated in the United States comes from fossil fuels, over 60%. When we consider where the electricity actually comes from in order to make solar cells, we end up with solar technology being about number 3 behind wind and nuclear, and about equal to natural gas with carbon capture. Next would be natural gas in a combined cycle, and last would be coal. You'll see others have a very different summary of the life cycle cost analysis of solar versus other forms of energy. And the reason for this is that they're taking the future power as being renewable and not hydrocarbon based. They're assuming that coal is going to be cut by 2/3 by the year 2030, which is only 6+ years from now, which is completely ridiculous. China is building coal plants at a rapid pace, and so is India. Coal is not going to just disappear. And then they assume that coal is completely gone in 25 years, which is not a realistic view of the energy mix. Then they assume that natural gas will be reduced by 50% in the next 25 years, which also is highly questionable. Natural gas production is still increasing and is a very clean source of energy. Making poor policy decisions, forcing a rapid transition away from fossil fuels in the U.S. will have many negative effects. Greenhouse gas emissions will go up globally, due partially to increased manufacturing needed for solar cells, batteries, and wind turbines, while simultaneously increasing the cost of energy, affecting the poor throughout the world the most. A few more things to consider when evaluating solar technology is the amount of land that will be required in order to place all the solar panels, and the amount of batteries required to store all the energy. Now, we've looked at batteries when evaluating electric vehicles and realized that they are very energy intensive and have a huge environmental impact, and that is typically not included in the life cycle analysis of solar cells. Another consideration is the infrastructure required to bring all this power to a usable location. Infrastructure requirements need to be looked at separately, and we'll talk about that in other videos. I hate to be the bearer of bad news, but solar technology is not the ultimate in electricity generation. I have to mine quartz from the earth and all the environmental impact of that. I have to melt the quartz using vast amounts of electricity that is primarily generated from the burning of fossil fuels, and I end up with a solar cell that has a low power density, meaning that it takes a lot of land to generate enough power to be a significant source of electricity. And if we try to do a very quick transition to all solar, we will end up actually increasing our greenhouse gas emissions significantly and having a negative impact on the environment. I hope this video has been useful in making you better informed about solar technology and being able to make better decisions about how we move forward with our energy policies. Like and subscribe if you enjoyed the video. Check out my channel for a deeper dive into the topics of energy and climate change.